Specifically for SPH4U or SPH3U on adding vectors in 2 dimensions using the law of sines and cosines. So you can go ahead and write, or you can, while I talk, or you can pause, because I will go too fast probably for you to do them both at the same time. At some point you'll have to pause. So the basic idea is to draw, if I'm adding 2 vectors, draw them, okay, approximately to scale. I'm too lazy to ever do anything to scale exactly. Though if you do it exactly to scale, then you can actually use a ruler to measure your answer and a protractor to measure your answer instead of doing the math. But as you draw it approximately to scale, you draw the vectors tip to tail, where the tip is the end with the arrowhead, and the tail is the other end, it's the back end. Okay. When you draw them, you don't pick up your pencil. You draw a resultant vector from the very start to the very end with the goal of making a triangle. And then you solve the triangle using trigonometry, which you would have learned all of this stuff, cosine law, sine law, in grade 10 math. Maybe grade 11 math if you didn't take grade 10 academic. Okay, so there's the sine law, there's the general form, there's the, cosine law, there's the sine law, and you should have all that down in your notes. I know I'm going fast, I'm just going to zip ahead. Please pause where you need to. But we're going to do an example. And here it is. This is the example we did the x and y components with. So we're going to do the exact same problem. We're going to add these 2 vectors, looking for what we call the resultant vector. And we saw this drawing before because we drew it in the first place. So you start by drawing the first vector, d1, which is 10 meters north, 30 degrees east. So just to show you a few things, I know this looks confusing, but here's my x and y, or north and east axes. So I'm drawing 10 meters when I have 30 degrees between my vector and the north axes. Okay, that's the first vector. And then I draw another set of coordinates, and I add my 20 meters. It's 40 degrees west of north, right? So there should be a 40 degrees right where my mouse tip is right there. But because that's 40 degrees, between this axis and up should be 50, right? Because I have to add up to 90. So draw my 2 vectors. Notice the arrowheads here and here. And then my resultant vector, delta d, is from where I very started to where I very finished. Okay? Now just looking at these angles again, so the 30 degree and the 50 degree should be clear. There's this little 30 degree angle in here, and how I got that is, if you remember grade 9 math, the Z rule. I'm sort of drawing, watch my mouse tip here. It's following along a Z pattern. And that means that this angle and this angle have to be the same. So I've got 30 degrees right here. And these 2, of course, have to add up to 90, so that makes this 60. So what I'm trying to do is find the angle measure that's across from what I'm looking for, which is delta D, right? So this ends up being 110, because the 50, I told you that earlier, and then this is 60 because these 2 have to add up to 90. So I have 110 degrees right here. Okay. Other things that I know, of course, is the magnitude of this side of the triangle and the magnitude of this side of the triangle. That's enough to use cosine law. What I want to do then is find this magnitude, and I want to find this measure here. And once I know this angle measure, the whole angle, then I can say how many degrees west of north or whatever my final resultant vector is. So looking at the cosine law on this particular triangle, this squared is this squared plus this squared minus 2ab cos of the angle across, right? A squared plus b squared minus 2ab cos of the angle across from it, right? So just going through that process and solving, you get about 25.2, which you may remember from the last question is exactly the same. Okay. The next part is to solve for the angle. And to solve for the angle, I use sine law, where I know that sine of this angle over 20 equals sine of 110 over delta d. Okay? That's where these numbers come from. And I solve for the angle, and I get 48 degrees. So this whole angle, now I've just sort of zoomed into this one part of my drawing, is 48. So if this was 30, we knew this from before, that makes this 18 because they have to add up to 48. So then my end answer is 18 degrees west of north. And I'm going to check mark that because the reason I know it's a good answer, because when I solved this using x and y components, I got 72 degrees north of west. And of course those two angles are the same. Okay? Let's just take a look at the original drawing again, by the way. So 48 degrees is this whole bit here. So this little bit here has got to be 18. Okay, so you can see cosines and sines way faster. So I think you should practice by doing the vector practice problem handout. Do question number 4. Try solving some of the questions or all the questions using both methods. And if you get that done, you'll be quite good at all this. Okay? All right, so that's it for vector addition in 2D.